So there are, for slope fields, you guys are going to remember that better. We kind of just reviewed that. Differential equations you're not going to remember as well. So what I want to talk about is there are 5 main steps to solving a differentiable equation. Number 1 is you got to separate your variables. Okay, that means you get y's on the left and you get x's on the right, and there's no mixing of x and y's. This means you're going to have to divide, multiply, and all that stuff. Okay, after you separate your variables, do y'all remember what we do?
Integrate.
We integrate. I'm going to integrate each side. And then the third one is you are going to solve for y, which means you're going to get y by itself. On the earlier differential equations, getting y by itself was pretty much done for you at the very beginning. But on the ones that we're going to practice today, it's a little bit more complicated. Now, if you're given an initial condition, you are going to plug in the numbers to find c. Some answers are just going to have plus c in them. Some, though, if you're given an initial condition, you can find c, and then you still got to write your final answer. I'm going to explain what I mean by this as we go through the problems. Okay, so 5 steps. Occasionally, you only have to do the first 3. If you're given an initial condition, you have to do steps 4 and 5, which you usually are given that. Okay, so let's look at number 1. So this is a non-calculator problem, and right now I have an x squared and a y on the same side. My variables are not separated. So how do I get the y over to the left-hand side? Divide. So it's 1 over y dy. The x squared is good to stay where it is, and we always move the dx over to the right-hand side. We've been doing that for a long time. Okay, that's the first step. In a free response question, you get a point just for doing that. Okay, then you need to integrate both sides. Okay, integral of 1 over y, natural log of y. Integral of x squared, 1/3 x cubed. And then don't forget plus c. Okay. Step 3, get y by itself. Remember, yeah, we need to rewrite it as an exponential because this is log base e, and so we need to say that y is equal to e to the whole other side. Now, right now, the plus c is in the exponent. You might be tempted to pick b, but it's not b. B has the number out to the side, not in the exponent. But what do we normally do with this? We move it to the front because, lots of reasons, but mostly because e to the c is just another number. The c up here and the c in front are not the same number, but they're both just numbers. Okay, so this says which one could it be? I don't know what c is, but I know it's some number. And so which answer choice fits this?
C.
Which one? It's one of those. C.
Oh, what am I looking at?
Okay. Let's move on to 2. Okay, 2. Solving the differential equation. Did y'all see how this says solution? Okay, we got it. Our variables are not separated. So what is the left, once we separate the variables, what is the left-hand side going to look like? Y, d, y. The right-hand side is going to look like 4x dx. So we're going to integrate both sides. Notice this is not a natural log problem. This is just 1/2 y squared. The integral of 4x is 2x squared, and then plus c. Now we have to get y by itself. I'm thinking the first thing to do is to multiply everything by 2. That will get rid of the 1/2. So this is y squared. That's going to be 4x squared. And I'm still just going to write that as plus c. Remember, c can change, but we don't really, we're a little loosey-goosey with that. Okay, now, the next step is obviously square rooting. But here's the deal. you have to decide right here, is this going to be a plus or a minus? This is a part of this unit that I did not devote enough time to because we had those snow days and I had to move it to after spring break and I didn't have a lot of time to teach this. And so this is something that kind of got put on the side until we would review. It doesn't happen on every problem, just on some problems. It's not plus minus, it's either plus or minus. And you can even kind of see, like, it's not A or B, it's one of these three. Here's how you know. Okay, take your initial condition. This means when x is 2, y is negative 2. In other words, negative 2 equals either plus or minus the square root of 4 times 2 squared plus c. Right, we plugged 2 in for x and negative 2 in for y. Should there be a positive or negative symbol in front of the square root to make this a good equation?
Negative.
Negative. A square root is always positive. Square root of anything, even square root of a negative, that's imaginary, but it's not negative. So we have to have a negative. So which answer choice can I get rid of just based on that? D, and because this says minus 12, I'm thinking the answer is probably C. That's just a test-taking strategy, but we're going to confirm that here in a minute. Okay, how am I going to find C? What could I do to both sides? Square. Square both sides. Bless you. That's going to get rid of that negative, and it's going to get rid of the square root. 4 times 2 squared, that's 16. And so C is negative 12, and my answer is C. Bless you. Okay, on a free response, I'm just pointing this out now. If this was free response, you would have to write your final answer. All right, now, why do you think they have this? What is this representing? Like, can you square root anything?
No.
No, it's the domain of the problem. Okay, that's why it's there. Okay, I'm not going to talk too much about that. Don't worry, like, do I need to write that? We're not going to worry about that. Okay, turn now to number, I'll know it when I see it. Next one. Number 12. First thing, we got to do the slip fill. So you guys practiced this at the beginning of class. What's the easiest number to plug in for either x or y? 1 and for y. When y equals 1, what does the slope equal? 0. Because 1 minus 1 is 0, doesn't even matter what the cosine part equals. So you should have this like that. Those are horizontal lines. Slope is 0. Okay, if you wanted to set up a chart, I noticed some of you doing this earlier. 0, 0. 0 minus 1 squared, that's 1. What's cosine of 0? If you don't know this, you got to study it. 1. So that's a 1 there. It's a slope of 1. Okay, 1, 0. This again would be y is 0, so it would be 0 minus 1 squared is 1, but it would be cosine of pi. What's cosine of pi? You got to study these. It's negative 1. So we got a negative 1 here. Okay, if I made this a negative x and that was a negative pi, this would still be negative 1. Okay, cosine is even. It's the same on both sides. And so, I mean, we could spend more time on it, but I'm not. Okay, what about 0, negative 1? Okay, so now y is negative 1. Negative 1 minus 1 is negative 2. You square that, you get 4. And then we got to do cosine of 0 again. So that's going to be 4 times 1, which is 4. So this is going to be positive 4, so it's going to be steeper. What do you guess is the other two? Negative 4. It's kind of bothering me because I feel like these ones in the middle are maybe a little too steep. Okay. So So there we got a point or two. I can't remember how it was split up on this, but we'll just say we got 2 points for that. Okay, part B, there's a horizontal line with an equation y equals c that satisfies this differential equation. Do you see a horizontal line? Yeah, it's right there, and so c should equal 1. They don't even ask us to explain it, but we get another point for that. Okay, find the particular solution. Believe it or not, I have this memorized. dy over dx is y minus 1 squared cosine of pi x, and my variables are not separated, right? So I'm going to go over to this side, divide that over, and I'm kind of speeding this up, sorry guys, but we don't have a lot of time left today. Okay, you separate your variables, then you integrate. Now here's the deal. You are going to have to do u substitution right here. We're going to let u equal y minus 1, and du then is going to equal dy. So this is going to be, like, if u is in the denominator, it's going to be u to the negative 2 du. Okay, I'll go ahead and write an equal sign over here. This is going to be, then when I integrate, negative 1, negative. And so really what this ends up being is, looks like this. So that's how you integrate the left-hand side through a u substitution. I know that was fast. Okay, the right-hand side is also going to be a u substitution. Because I've already used v, I probably should use a different letter. I mean, I already said u. I'm going too fast. It's okay. U, I already used it. V, that's what I'm going to do. Everybody watching the video could be like, this Brooks is losing it. It's okay. Okay, what do I need to do with this pi? I need to divide that thing over. So that's going to go out to the front, and this is going to become cosine v dv. What is the integral of cosine v? Sine v. And so when I integrate this, it becomes sine of not v, but pi x. Okay, I went through that integration part really quickly. I know I did. All right, let's just leave that. We've been integrating a lot, so that's why I kind of went through that fast. Okay, now I have to get y by itself. So I'm going to go up here. First thing, let's get rid of the negative. Let's do that by multiplying both sides by a negative. I can leave it as plus c. You don't have to write it as minus c again because c is just a number. Do y'all remember how we dealt with this? We just did it to the other side. It's like you invert one side, you can invert the other side. Okay, all of that's in the denominator. So what's the last thing to get y by itself? Add 1. Okay, I have now successfully gotten y by itself. Oof, we can breathe here in just a second. Next, I need to use my initial condition. Okay, so watch this. I'm going to plug 0 in. I'm going to go negative 1 over pi sine of pi times 1 plus c plus 1. Sine of pi is 0, so that whole thing goes away. To spare you the drama and let you know that c equals negative 1. So your final answer, you have to write a final answer, is this. Okay, I went through that really fast, and I'm going to tell you that I think this was the hardest one. And so we did it in super speed. Okay?